Okay, so this is problem 5.18, and in this problem, given that the threshold voltage is 0.5 volts and the device transconductance Kn, which is equals to the process transconductance times the aspect ratio, is equals to 1.6 milliamperes per square volts. If the desired drain current is 50 microamperes, and the MOSFET is designed to operate in the saturation region, we need to find VGS and the minimum value of VDS so that this condition of saturation region, of saturation mode operation of the MOSFET is satisfied. And then we have to repeat that for ID equals to 200 microamps. Now, if you remember the curve ID over VDS, here's ID. For some specified VGS, we have this behavior here, right? So it looks like this, ignoring the channel modulation effect. So this is for VGS1. And if we change VGS, we get another curve here if we increase VGS. Let me draw it different, draw it this way here. So it's easier for you to see the curve. Now what's operation in the saturation region? So operation in the saturation region is that all this area at the right of this curve here, including that curve. So this curve here is exactly the edge of the saturation operation. And in this curve, green here, we have that VDS is exactly equals to the overdrive voltage. Okay, so that's the reason we have to find out the minimum VDS. Because if VDS is equals to the overdrive voltage or greater than that, then the MOSFET will operate in the saturation region. But how do we figure out those values of VDS? So we need to calculate the overdrive voltage that we need, and basically the answer for VDS minimum would be like the overdrive voltage or something greater than that. And to calculate VGS, we can use the equation for the current in the saturation mode. So we know that the current ID in the saturation mode is 1/2 of the device transconductance times the overdrive voltage squared. So if we isolate the overdrive voltage in this equation, right, that's one of the quantities that we need to define, because with the overdrive voltage we can define the minimum VDS and VGS, because I will just show you another equation, but let's first isolate VO overdrive here. So it's the square root of 2 times ID divided by the device transconductance. Okay, and we know that the V overdrive is actually VGS minus the threshold voltage. Okay, so if we know VOV here, the overdrive voltage, we know the minimum VDS during source voltage, and we can also calculate the gate source voltage for that specific current. So in this case, I'll call VOV1 for the current ID equals to 50 microamps divided by the process transconductance, which in our case is 1.6 milliamps per square volts. And this gives us overdrive voltage of 0.25 volts. Okay, so that's the first result that we got, which means that VGS1 is equals to that 0.25 volts and again this one goes to the left hand side here, or in our case the right hand side, plus 0.5 volts. That's our threshold voltage, and this gives us a gate source voltage that's 0.75. So this one here is our first result, right? And we also can calculate VDS mean. So VDS mean, remember, to start operating in the saturation region, we must satisfy this condition here, which corresponds to those points here. When we have, or it corresponds to this green line, but because we just have those two curves for the relationship between ID and VDS, basically in those points here, VDS is equals to the overdrive voltage. So VDS mean is equals to 0.25 volts, and in general VDS should be greater or equals to 0.25 volts, okay? But the minimum is 0.25, the overdrive voltage. And for the second case, we basically follow the same rules, right? So we calculate V overdrive 2, which is going to be square root of 2 times 200 microamperes divided by 1.6 milliamps, and that gives us 0.5 volts, right? Now we can calculate VGS2, that's equals to that 0.5 plus 0.5 from the threshold voltage, and that's equals to 1 volt. So this one here is VGS2 for the new current, and VDS mean is equals to the V overdrive 2, that is 0.5 volts, or VDS should be greater than 0.5 volts. Okay, now if you want, we can plot these results here, and it's going to be basically similar to the curve that we had before. So here is VDS, here is ID, and then we have VDS equals to the overdrive. So let me call this one here V overdrive 1, and this one here V overdrive 2. And let's put the currents here. So this one is ID 1, and this one here is ID 2. So exactly at those points here, and this one up here, so let me see, around here, those are the points where the MOSFET starts to saturate. So the first curve would be something like this, right, and then it keeps flat. In the second curve, it would be something like this, and it keeps flat. Okay, so that's the behavior that we have for those two conditions. Okay,